In this lesson, what we're going to be focusing on is lines of best fits, right? So if I have a scatter plot of some data, all right, what I can do is I can give them lines of best fits, all right? Now, what is a line of best fit? Is essentially like if the linear relationship between your two variables is strong enough, then we can draw a line that sort of represents that relationship, okay? And to draw that line, we have a bunch of options. We can have a line of best fit by just judgment, all right? So in this case, I'm assuming that the line of best fit is something like this, right? Obviously, it's not linear enough, but I can say that maybe is close enough, all right? So that's one way to go about it. The other, a bit more stronger way to go about it is to find the mean x value and the mean y value. So find x bar, which is the mean x, and the y bar, okay? Place that point on the scatter plot, all right? So place it on the scatter plot. Then connect a line, draw a line through it such that the number of points that are above that line is about the same as the number of points below it. All right, approximately. Obviously, sometimes it's not possible, so approximately. So, for example, I can mark my mean x and y to be here, and with this data, I can either have a bunch of lines. I can have this line that goes through that point. I can have this line that goes through that point. I can have this line that goes through a point. Now, this one seems to be having more. Sorry, I'll just point out which one I'm looking at. This one seems to be having a fair amount, right? So this is kind of reasonable. They're the same number on either side. This one, it has a lot more of them on the left hand side than it does on the right hand side. So we are not going to be considering this any further, right? And this one is also a good one, all right? Because it has kind of a similar number, right? And I would go with this one, because it represents the trend of the data a bit stronger as well. So when you have this sort of situation where two lines are kind of similar in their best fit, right, in their fit, you go with the one that represents the data better. So in this case, this will be my line of best fit. So there's further things you can do with it, right? Once you have your line of best fit, you can interpolate and extrapolate with the line. So what that means is essentially if I draw this line, right, whoops, let me bring that back. All right, and essentially what I'm saying, if this was the end of my data, right, this is where my data ended, I can extend this line further, and then this is called extrapolation because we are going outside the data that we have. Similarly, if I'm looking at information here where there's actually no data points in that region, right, that is called interpolation. Okay, and that's just a term you should probably be knowing. And after this, it's just drawing, using this line of best fit to estimate values, right? So if I have nx value equals 10, what does my line of best fit suggest that my y value is? All right, and that's kind of the extent of how hard this is going to be. So just be able to use that, just be able to find the mean and for both values and be able to plot it and get a line. That's all there is. It's not a very hard topic, okay? But it does get a bit more complicated when you involve a more thorough process. So that obviously this is kind of eyeballing stuff, right? So to do this, to get a better one, is we use a different method, which is called the least squares regression. Okay, so this is something you probably have to do on your calculator. You're not going to be doing it by yourself. But essentially, you put this into your calculator, right? You put your data points, and it gives you the line of best fit. And essentially, the way this works is it finds the distance between each of these points, right? And your current line is whatever it is, and it tries to minimize that distance. So the distance is squared because you can have positive and negative distance. So you square it to get like just the absolute value of the distance, and you want to minimize that square. That's where the least squares come from, right? And you don't have to do that by yourself. Like I said, you just put it into a calculator, it pops it out, and then you use it to find out different values within the data set, similarly as before. If my x is this, what's my y? Okay, so that's kind of all there is to it. Again, just mainly do some practice. If you have any questions, feel free to ask. That's all there is for this one. Hey guys, two things. If you do have any questions regarding the content we just covered, just go ahead and drop that in the comments. I'll make sure to get to that as soon as possible. And secondly, if you like the video or if you got anything that was useful from it, make sure to check out the website, Prep Folders. There's so many more videos like this, so many more resources, practice questions and all the lot. So just go ahead and have a look. If you need help, there's some tutors and mentors there as well. So just have some fun over there. And yeah, we'll see you on the other side.